Well, hello everyone, this is KP the Math G, ready to go again. I have been busy, transplanting some butternut squash, along with planting some things out in the garden here and there, such as corn and okra, cucumbers, whole beans, tomatoes. Got some potatoes rather, in the greenhouse, hoping that they grow what you call slits. You cut those off and you plant those into the ground. But anyway, got something going, got a few garden things going, and now it's time to do some calculus. How about that? And I love doing that, and I'm sorry that I've been away for so long, but here and there, but I got to take care of a little bit of business from time to time, and I believe you understand that. But needless to say, the 2010 free response, and what I'm trying to do is get some questions that I have not presented to you before. You've seen a lot of things out of I forget how many videos I have now. 100, and this will be the 118th one, I believe it is. So out of 117 videos, you've seen quite a bit, and there's still a few more things that I have not yet discussed. And so I want to discuss that today, and hopefully maybe tomorrow or the next day get into this 2010, couple of those questions that I want to address from there, and then look at some of those things. So here we go with this problem here. It has to do with snow accumulating on a driveway. And so snow accumulates at a rate of, well, F at t. So F at t is equal to 7 times t e to the cosine t cubic feet per hour. So this is the rate. So that's what you got to do, is you've got to look at this. So rate, so I'm likely going to take a antiderivative or a definite integral from 0 or something to something, you know. And so I'm kind of getting to that point where I need to, when I see that, that's probably going to be a definite integral. If I have to find out how much snow, which is really what it says, how many feet of snow, alright, so have accumulated by 6 a.m. Alright, so that's what we're talking about. The rate at which Janet removes the snow. So you got to understand, this word is accumulates. So snow is coming down. She is trying to remove the snow from her driveway. And she removes it according to, instead of F at T, of course, this is the accumulation of snow as F. G is the removal of snow. And G at T is, of course, as we can see, a piecewise function. It is 0. Of course, she did not get up until, or start moving around and going outside until 6 a.m. So from 0, that would be from midnight, T between 0 and 6 a.m., 125, and that again, that's cubic feet per hour. This is a rate right here that we're talking about, by the way, for T being between 6 and 7, not including 7, and then 108 feet. Let's see, yes, yeah, that is cubic feet per hour. So yeah, that is cubic feet per hour. Just making sure that I got this as a rate from 7, T equals between 7 and 9 a.m. So we're looking at from midnight to 6 a.m., 6 a.m. to 7 a.m., 7 a.m. to 9 a.m. So now we want to see how many feet of snow have accumulated by 6 a.m. Obviously, she hasn't started removing snow until 6 a.m. See, she removed, there's a rate of 0 cubic feet per hour. Yes, that is per hour. Yes, it is. Alright, so we're wanting to, obviously by now we should be able to understand that if we see the rate, then all we do is we integrate, and of course from 0 to 6, and that would be alpha t dt. Now, one thing that I've observed that I could do, and I'm sure you may have already figured this out, okay? And I heard it in a workshop several years ago, so it kind of did come back to mind. And I went ahead and I hit the y equals button, and I'm into, I don't know if you can see that, but y sub 0 is another problem from another question, but y sub 1 is what we're talking about. 7xe cosine x. I am not sure you can even see that or read that, but let's see how close we can get. Oh, I don't know if you can even read that, but anyway, that is in y sub 1, and so I went ahead and plugged that in there into y sub 1, just like that. And then I get out of there, and I found out that you can do this. You can actually, in this case, instead of alpha t, of course, I do y sub 1. You can go ahead and set up the integration symbol like this, and then you can plug in the numbers from 0 to 6, and then you can actually go to second y bar, and actually you might, in your calculator, you might have bars, and then you go to y bar, and then then you can pull that up over which one you want to do. So I just wanted to so first of all, I get into math, and I'm just going to go ahead and do this again, even though I have done it before. So 0 to 6, alright, and then I want to, now that I know that I've got it in y1, then I can go to, to me, I go to alpha y bar. That's, and then I can get into y1, and then I can hit enter, and hit enter again, and the answer should occur. Alright, so I don't know. I have done it before, so let's see. I've already done it before, so the answer there is 142.275. Alright. Sometimes when I hit enter on this one, I don't know. Okay, it's not coming up for some reason. Alright, anyway, I've already brought it up another time before that. Alright, so there it is, 142.275. So instead of waiting on that to come up, I've got this on my phone, that's why I'm doing this. Okay, so this is about equal to 142.275. So about equal to 142.275. Now remember, this is not cubic feet per hour anymore. It's just down to cubic feet, okay, of snow. Alright, that's how much has accumulated. You should know that by now, and I'm just saying, just out of review, and just in case you don't remember, when you see the word rate and it's asking for how many feet or how much something is, then you've got to take the definite integral from 0 to 6. That's what you got to do, and then it will come up with your answer here. Okay, there it is. All right. That's the A part to that. I don't know how far I wanted to get with this. I actually want to look at C and D, and maybe I have to do that on another video. So I'm going to try to move along with these just a little bit. I've already done them on the calculator, but there it is. It did finally show up on this one. Alright, I've got it. So there it is. Now the second question is, let me write this down. It says find the rate of change of the volume of snow. Now at 8 a.m. Okay, so the rate of change. Okay, so let me put that down here. Alright, B part, I'm just going to abbreviate very quickly because of lack of time. So we're looking for the B part, the rate of change, rate of change. I would have it on the other side, but I like to try to put everything on this side if I could. So I'm trying to keep everything on this side. Rate of change of snow Alright, the rate of change of volume of snow. Alright, volume of snow. Volume of snow. And they're trying to say at 8 a.m. Alright, so we have to look at the piecewise function for, now remember she's removing snow, so 8 is in this interval here, so we're going to use 108. She is removing snow, so we're going to show that she is removing snow. Alright, we don't look at it from 0 to 8, just at this interval here. Okay, be very careful about that. I had to think about it a little bit, and you just have to remember. Now that's the easy part right here. Now what we got to do is, this is a rate, so since this is already a rate, we're going to use this right here. Alright, now one thing that I have that we can still do is I can still use the y bar, since I've already have this located in y1, and I'm sorry you cannot see that, but what I have here, and I'm just going to show you, I have here y1 right there is equal to, and I have this function here, 7x e cosine of x, like that. And so now that I have that, I can just do I do alpha y bar. Alright, and I want to do y, okay, I'm sorry, I've got ahead of myself, and let me do a little bit of deleting here. Got a little bit ahead of myself. I'm sorry, please bear with me. Let me get out of this first. Now you can get into y bar again, and you can hit, in this case, y sub 1, and then in parentheses, since it is 8, you can put that in parentheses, and immediately you'll get your answer. I got 48.417, so 48.417 minus this 108 here. I already know what the rate is at t equals 8. T is right there, so can't worry about these other two. The piecewise tells me to look at this. So this is the number that's associated with this 8 here. Alright, so this is minus 108. Alright, that is so easy to figure out. Once I figured out I could do that Y bars like that. I hope your calculator is much like that, and that you can use the same that the same way. So then once I got out of that, I can figure out the answer to this. So let's see what I did. I've already figured it out before. It's a negative 58.583. Negative 58. So that's equal to, whoa, this one's not even writing. Okay, so that one's going in the garbage. Okay, there we go. I had two black markers. Okay. Equal to negative 59.583. Negative 59. Negative 59 point. I always have to keep looking. 583. 583. Now, what is this? In cubic units, what is this? Yeah, because you're comparing, this is the rate of change. This is still in cubic feet per hour. So that's what we're going to do here. I'm going to write it in this blue. It looks like this black is trying to die already, and that's a brand new black marker. Go figure. Cubic feet per hour. And you're still dealing with this. This is a rate minus this rate. And so you got to stick with rate of change. That's all you're doing. And actually you just say, if you want to start off saying F at t minus g at t. That's what you're dealing with. Rate of change. Okay. Alright, there it is. Alright, the rate of change. That would be, find the rate of change of the volume of snow. Alright. Now then, this C part is really what I want to get into, and I may have to flip the board over for this one. Okay. The A and B was fairly simple. I don't know. I may have a little time to do C, but you know, those are the ones that, I mean, okay, so just remember when you're dealing with rate of change, how much is accumulated minus how much is removed, and that's the rate. That's a rate, and this is a rate here. So make sure you get the correct. It's been, say, six and a half hours. Okay, t equals 6.5. Then you would have picked this number here. Okay. All right. Now let's go ahead and deal with C part. All right. So let's see. It says, and I may just have to turn the board over. It said let H. Let H. Now we're dealing with a different function at here, H at t. Alright. Represent the total amount. I'm just going to abbreviate that, of snow. Alright. And that's going to be in cubic feet, of course, because this is not cubic feet per hour, so that would be in cubic feet. So we're going to assume we know that, but yeah, that Janet has removed. All right, so that Janet has removed. And I will say at any time t, all right, at time t after midnight. Okay, so we're going to leave it in terms of t. After midnight. Okay, so we have to come up with this piecewise function, remember now, is the rate at which she removes the snow. What they're asking for is the total amount, which means we are going to have to set up a definite integral, aren't we? Alright, so we have to have 3 of these. Alright, we would have to say that from 0 to 6 that h at 0 is going to be 0, isn't it? Okay, so we should know that because she's not going to start until 6 a.m. Okay, so in other words, for this one right here, we could go ahead and do this. Now let me show you how to set this up. All right. So let's say, now let me erase this. Okay, just wanted to show you that. All right. So so when we're talking about t being between 0 and 6. All right, for that we have h at 0, which we've already know that she hasn't done anything yet. Okay, she hasn't removed any snow. All right, but plus, all right, so we're integrating from anywhere from 0 not to 6, but anywhere time t in here. Did she get any snow off? No, of course not. Now instead of g at t, since this is already t here, we need another letter, and we could use x if we want to. They use s for snow. I guess s means for snow, but then ds right there. But then of course there is no, she has not removed any snow yet. So this amount of snow is 0 plus 0, which is 0. Alright, so there is the first one there. Alright, so that's the first one. If they say for this, if you want to slide that in there, for this interval here, for this time interval, you have this right here. Alright, you will have, from 0 to any time t between this time here. Okay, that's what we're talking about here. Alright, let's go ahead and flip the board over, and we'll make that comparison over here, since let's look at g at t again real fast. I probably should have went ahead. Okay, we know that this is we're talking about a rate here. Alright, so we know from t being between 0 and 6, here's t being between 6 and 7, and then t is between 7 and 9. Okay, and then of course, looking at that, well, g at t, well, equals, I got it backwards, okay, equals 125, I'm sorry about that, and then equals 108. Alright. Okay, g at t does equal it, so for these intervals here, okay, I got ahead of myself on that one. Sorry about that. So actually, h at t is going to be h at 0 plus, and again, anywhere from 0 to t. Alright, and then now instead of g, it's still going to be g, but g at s ds, and of course that is 0 plus 0, 0 plus 0, which is 0, because she hasn't gone outside to take the snow away yet. Alright, so now let's do another. Okay, and of course this is for, let's go ahead for t being between 0, and 6. Okay. Alright, there's that one. Alright, let's go ahead and put this one down for, now we're looking at t being between 6 and 7. We're still using the same intervals, aren't we? Okay, so at 6, this is h at 6. We start with this one here, each time here. So h at 6 plus. Alright, now again, this time we're going from 6 to t. Somewhere between, t is between 6 and 7. This could be 6.25, this could be 6.5, 6.9, whatever, or even 7 for that matter, but we're just going to stick with t being somewhere in between there. And then, of course, again, g at s ds, but again, at 6 now, going back here, no snow at that time, she's just started. Okay, remember the equal sign is not associated with the 6 here. Alright, so plus, now, this here is, she has accumulated, this is the rate, so we would say 6 to t, this would be 125 ds, right? So that's equal to, so 0 plus that is just, 0 is, 0, so we're saying this is 125 t minus 125 times 6. And of course that would be 125 times t, take out the 125, t minus 6. Okay, you can do that. Okay? Alright. And of course the third one, we'll just have to put it up here somewhere. Let's see, I should have wrote a little smaller, right? Alright, so now we want to do, alright, so h at 7. Alright, so let's say for t being between 6 and 7, no, I'm 7 and 9, I'm saying. T being between, okay, let's see, there we go, 7 and 9, so for that time, we have now h at 7 plus integral from 7 to t. So each time you're just going from the next, anywhere the beginning of this time period. See, the beginning of this hour here. Okay, so from 7, the beginning, any t anywhere between here and here. So any t that's between here. So you have to do that between 7. That's why we do h at 7 here, plus this here. Now again, this is, in this case, it is h at t, but in this case it's now, well, it's 108 ds. And of course, this would be h at 7, which we already know is 125. 125 plus, let's go ahead and deal with this the same way down here. Alright, so 108, once you see a pattern going, I like to just stick, so instead of t minus 6, we're saying t minus 7. Okay, there it is. I don't know, can you leave it like that? Maybe. That may be okay. This is okay too. Either one is going to be alright. Alright, so that is your piecewise function. This, and this. Okay. Alright, there it is there. And that's something that you just needed to be aware of. Okay, because if you have a piecewise function and you have to this, you have a piecewise rate function, and this is talking about how much has she shoveled off. All right, how much snow has she gotten rid of? Okay, then we need a piecewise with these same intervals. So we have to have 3 of them here as well. So 1, 2, 3. All right, I'm just going to stop there. I don't know. Let's see. We could go ahead and do the D part. I just don't know how much time I'm going to have because my camera is limited in time. So I think I'm going to just stop right there. We may just go ahead and do D a little bit later. Oh, I want to do it right now, but anyway, I think this will do for now. So I'm just going to go ahead and stop here, and then we'll probably pick up on D part a little bit at another time. But once again, in way of review, just real quickly, this rate right here, if it says how much, well, all right, integrating from 0 to 6, that right there, that was A part. B part, rate of change, all right.